Lesson 49, the superpositioning of waves. And let's try, oops, we're still on Beethoven here. Let's try and demonstrate that with our wave on a string. So I'm going to send a, no, this time we're going to oscillate. We're going to oscillate it. And we're going to get rid of the dampening. There we go. Okay. And you'll notice, let's watch this wave for a second. You'll notice that it seems to be getting bigger and smaller. Sometimes it's big, sometimes it's small. Ooh, it got really small there. And then it gets big, and then it gets small again, and it gets big, and so on. Let's just watch that in slow motion. And let's put a ruler up there. So you can see the wave is kind of small there. You can see how it's not hitting the ruler, and all of a sudden, oh, it does hit the ruler. It's going higher than the ruler. Let's put a normal motion. And yeah, there we go. So this is a superpositioning of waves is responsible for this, why the wave is getting bigger and smaller. Let's stop that and go on to the lesson. And what's happening here? Well, we learned in our last lesson that if a wave hits a boundary, then it reflects. So here's a wave. Oh, that's not a wave. Here's a wave. Hits this boundary and it reflects, comes back upside down. Oh, I didn't do that very well. Should come back upside down. Right? Now, what happens if the crest, if I send a pulse going this way, and then over here I have another rope and I send another pulse going this way, what happens when those two waves meet? And the answer is, if they're both crests, in other words, they're both facing up, when they meet, they will pass through each other, but at the point where they meet, they will actually, let's say that this is 1 and this is 1.5, they will meet and they will create a wave that is, yes, you guessed it, 2.5. So in other words, they will add their amplitudes together, creating a wave that's 1.5, and then they will just pass through one another. So then the 1 will form over here, continue going that way. The 1.5 will form over here, continue going that way. So this is called constructive interference. But what happens if a wave going this way, that's again has an amplitude of 1, meets a wave that's going this way? And let's say the amplitude of that wave is 0.7. What happens when they meet? So this, in other words, a crest meets a trough. And the answer is they will destructively interfere, and so you will subtract their magnitude. So when they pass, they will create a wave that looks like this, that is 0.3 in amplitude. And then once they pass through one another, then again, the 1 will resume going in that way, and the 0.7 will resume going in this way. So this is called superpositioning. It's when one wave touches another wave or interferes with another wave, and they produce a third wave, so to speak, or they produce the net sum of their amplitudes. If I have one that's 1 going this way and one that's 1 going this way, what will they produce? And the answer to that question is they will destructively interfere and produce nothing. So you will get a nothing point there. And if you go back to the FET demonstration, let's restart this and go. There you go. Occasionally, you'll see places where the wave does not, like right there, you see, you'll see places where the wave does not seem to move. Ooh, that was cool. That was complete destructive interference when it went completely flat like that. And the place where the wave does not seem to move, it seems fixed on this line, like right there a second, that's where you have complete destructive interference. Okay, so let's go back now and fix all this. So we talk about superimposing, means one wave gets superimposed on another wave, and the key here is right here. The The displacement of the medium caused by two or more waves is the algebraic sum of the amplitudes of the waves. All right, so if one is up and one is down, then you essentially subtract them. If they're both up, you add them. If they're both down, you add them. One's called constructive interference, one's called destructive interference. So if you have a crest meeting a trough, you're going to get destructive interference. If you have a crest meeting a crest, you're going to get constructive interference. If you have a trough meeting a trough, you're going to get constructive interference. And then it goes through some examples. So when these two waves meet, they're going to form a crest of 3, magnitude 3. There it is, and there's a good depiction, and there it is, magnitude 3. And then they just continue. Once they've constructively interfered with one another, then they just continue going their own merry way. And this has to happen, because if this did not happen, if two waves could not pass through each other and then resume exactly as the way they started, then it would be impossible for two people to speak at the same time, because their sound waves would destructively interfere, or you wouldn't be able to. They would not pass through the other wave and reach the person's ears. So this is why that has to happen. And then there's an example here of destructive interference, and so on. And when you get complete destructive interference, you get a point where the wave doesn't move. And that is it for superpositioning of waves. And that very nicely leads to lesson 50, which is standing waves, coming up next.